Okay guys, in this video I'm going to show you how to make your own LEDs for your RC plane, truck, car, or whatever. You can buy LEDs already for your plane, or you can just make your own. Here's a sample LED that I've wired up here. I have it connected into my receiver. This is an SMD LED. These are some of the brightest LEDs that you can get. I'll turn it over so you can look at the back. Let's unplug it from the receiver so you can see what it looks like. So here it is with the servo connector on one end and the LED on the other. So take a look at the LEDs that I installed on my Bixler glider here. You can see I've got red on the tip here, green on the tip there, and white on the tip back here. None of mine blink, but if you want blinking LEDs, you can purchase an LED that already has the integrated circuit in it. That'll make it blink. We're going to try doing this using inexpensive parts or just extra parts that you might have lying around. Okay, so let's talk about what you're going to need. You're going to need an LED. SMD LEDs are some of the brightest, and you can get them in light strips like this one that I got from Hobby King. You can also get them on Amazon or eBay pretty cheap, and you just unsolder one of the LEDs off of the light strip and you can use that. You can also use 3mm and 5mm LEDs. These can typically be salvaged out of electronics, or you can just buy them off of eBay pretty cheap. You can get a package of 10, whatever color that you want. If you want ones that blink, you can also get those. The blinking built in. Pay attention to how the luminosity or the brightness of the LED. You might want some that are brighter, you might want some that are a little bit dimmer. Another thing to look for is look at how wide of an angle the LED is advertised as. Some will light up and they'll shine directly straight out. Some will kind of be a little bit more diffused. Some guys will take the LED lens and they'll sand it down a little bit to diffuse the light a little bit more. But from my experience, I found that the SMD LEDs seem to be the brightest ones that you can get if that's what you're after. You're going to need some old wire, enough for a positive and negative run. This is just some wire that I salvaged from some electrical components. Now the gauge of the wire or the thickness of the wire doesn't matter too much. You can use almost any gauge that you're comfortable with. Of course, the smaller it is, the less noticeable it's going to be. I've used wire as small as 44 gauge magnet wire like this, which is almost like thread size, really small. Network cable or telephone cable has, like this right here, has these twisted pairs inside it. You can cut some of this and cut it to the length that you want. Cut this outer sheathing off, peel back that, and you can get the twisted pairs out of it. This wire I think is around 22 gauge usually, and it makes good wire for running LEDs. Probably more than you need, but works good. You're going to need a male servo connector. If you ever have a bad servo, don't throw it away. You can just cut off the connector here, the male connector, and use something like that. You can also buy the male-to-male servo connectors like this one from Hobby King or other places, and just cut the wire in the middle and you've got two connectors right there. Yet another option is you can buy these male servo connectors with the pins not put together yet. You put the pins on your wires and then you slide the pins into these servo connectors. You can get these at Hobby King pretty cheap. You're going to need a resistor. We're going to calculate the resistance of the resistor later. You can salvage resistors out of old electronic equipment, or just do what I did and go on eBay and buy a variety pack of resistors. You can get these really cheap. You're going to need some heat shrink to cover your connections. I like to use heat shrink that's just about twice the size of the wire that you're trying to cover. Okay, so let's review some of the tools that you're going to need. You're going to want a nice soldering iron, some good solder. I recommend using 6040 rosin core lead solder. If you're using SMD LEDs, which are really small, you might want to use some small tweezers. You'll need some wire strippers, either larger size for larger size wire, or if you go around 22 gauge or smaller, some smaller wire strippers. A set of helping hands will help you hold the wire. This is optional, but it does make it easier. If you're using the network cable and you have to cut the outer sheathing of the wire, you'll need some sort of blade or a knife where you can cut that out. If you're using heat shrink to cover your connections, you'll need a heat gun or a lighter to shrink your heat shrink. You'll need a multimeter for testing receiver voltage. So let's talk about how this works real quick. So when you take your LED servo connector here and you plug it into your receiver, it gets power from the receiver to light your LED. Now when you plug this into your receiver, you can plug it into any free port on the receiver. Now if you don't have a free port on the receiver, what you can do is you can unplug one of your servos that's already plugged in there. You can plug in a Y connector like this one, which splits it, and you can plug this into one of those Ys, and it won't hurt your servo at all. So let me just demonstrate to you. I have a servo Y connector here with the LED connected into one side of the Y and the servo connected into the other. I'm going to just test it and show you how it works here. The servo is still working even though I have the LED connected to the other end. So when you look at a servo connector, the brown wire is actually going to be brown or black. It's going to be negative or ground, same thing. And the red wire that's in the middle is going to be your positive. And the yellow wire here at the bottom is a data wire or a control wire. And we're actually not going to be using that. We're just going to be using the power from the brown and the red wires in this case. So knowing that, let's say you have a servo wire running to an aileron in your wing. What you can do is you can install one of these Ys in your wing, connect this to that servo wire, have one go to the actual servo and have the other one go to the tip of your wing where you want the light. So you're just borrowing some of the power that was going to that servo. You don't have to worry about not having enough power. These LEDs take very little power. I think the most that I've seen is that these SMD LEDs take about 50 milliamps of power. Your receiver is going to deliver about 5 or 6 volts of power, usually somewhere in there. Your LED is going to only require 3 volts of power. So what you do is you put a resistor in line, mine's right here underneath this heat shrink, so that you can bring down that voltage for the LED. So how does the wiring look? It's very simple. You have coming out of your receiver, you're only using the positive and the ground wires connected to 2 wires going out to your LED. Positive goes into your LED, comes out of the LED on the negative, it goes through the resistor and goes back on the ground wire back into your receiver. I'll throw a wiring diagram up on the screen to help you out. It's very important to put the resistor in line so that you don't burn out the LED. When you wire up the LED, it is polarized, and that means that the current can only flow in one direction. So you want to make sure you have the positive connected to the positive end of the LED and the negative connected to the negative end. Okay, so you're going to have to determine the resistance you're going to need on your resistor. So what you want to do is take a multimeter, and you're going to look on your receiver. We're going to test and see how much voltage is on the receiver. Typically this is produced by your EEC or your BEC. With the meter, you want to touch the negative pin and the middle pin, okay? And you can see my meter's reading 5.0 volts. So I have 5 volts being supplied to my receiver. We're going to use that to calculate the size of the resistor. Okay, so to calculate the resistance for your resistor, you want to come to this website, ledlinear1.org.
POSITVE.org. I'll put a link to this website in the video notes. You're going to fill in these 4 blanks right here. For the source voltage, you're going to put the voltage for your receiver. So mine was 5 volts. For the diode forward voltage, you can get that from whomever you purchase your LED from. If you don't know what it is, you can find a similar LED and off of eBay and just use that forward voltage. Please note that different color LEDs have different forward voltage, so that means the LED uses 3.2 volts. For the forward current, also you can get that from wherever you purchased it from. Mine is using 50 milliamps, so I'm going to put that in. And number of LEDs is 1. Then you're going to click the radio button for the wiring diagram and click Design My Array, and it tells us right now that the resistance has to be 39 ohms. Don't worry if you don't have a resistor that's exactly 39 ohms. You can just find something that is greater than 39. It's just going to make it a little bit dimmer. It's really not going to hurt anything. Also, don't worry about which side that you put the resistor on. You can put it on the positive or the negative. I put mine on the positive. This one's showing it on the negative. I've done it both ways and it seems to work just fine.
First, let's figure out how long of a wire we're going to need, and we're going to cut it. I'm going to use my twisted pair wire that's inside my network cable. That's the length that I needed. Since I'm using this network cable, I'm going to have to remove some of the outer sheathing, so I'm going to cut right along the sheathing there so I can pull out these wires here and pull them out of the sheathing. I actually had 4 pairs of wire in here that I can use. Okay, so now I have my wire ready to use. Okay, on one end of the wire you want to strip off about a ½ inch off each side. You want to get your servo connector ready. Make this if you have to, but I'm just going to use this one from this old servo. So I'm just going to cut it, and then I need to separate the wires a little bit. So I'm going to use a knife here to just run it down between the wires to separate them. Note we're only going to be using the red and black wires. Okay, you want to strip about a ½ inch off of each of these, off the red and the black wires. Next, you want to cut some pieces of heat shrink to slide over your long wire here. I suggest maybe 3/4 of an inch. And you're going to slide those over the long wire here. Now you're going to take your helping hands and you're going to put your wires in your helping hands. First we're going to solder the positive wire here. So we're going to solder the orange wire, in my case, to the red wire. Have them meet just in the middle. I put a little solder on each of these already, and what I like to do is just take my soldering iron and put it right between the 2 wires and move it back and forth so it heats both of them at the same time, and then just let them sit together like that, and hold them, let them stay still so the solder melts together, and then just give it a nice little tug, make sure it's holding together. Do the same thing with the ground wire here. I'm going to solder them both here, hold them together, hold them still, and the solder's melted together and we got a connection. Again, I'm going to test it, make sure it's connected. Now we can slide the heat shrink over the wires, make sure the heat shrink's in the middle of the connection. And let's wait to do the shrinking till later. I like to make sure that the circuit's working before I shrink it. Okay, so we want this resistor to go on the positive end of the wire. So rather than connect it right here to the positive end, what we're going to do is we want it to be about the same length wire as if it was right at the tip, so that when we have our positive and negative sticking out, they'll be the same length. So what we want to do is we're going to just we're going to just cut the wire right before the resistor. So I'm going to cut it right there. Okay, and then we're going to strip back about a 1/2 inch, so we're going to be soldering this to the resistor, like so. So I'm going to take this and put it in, and I'm actually just going to kind of twist it around the resistor a little bit so it holds on nicely. Let's put that in my helping hand. There we go. Some solder here. I usually like to heat up the wire a little bit before putting the solder on there. It'll stick better. And I'm going to heat it over the whole joint. Take it off, tug on it, make sure you got a good connection. It looks good. So now if we check this out, you'll notice that our negative end here and our positive end, which has the resistor on it, are about the same length here, which is what we want when we connect it to the LED. Next, you want to cut a piece of heat shrink. You want to cut it so that it's long enough to fit over the entire resistor and cover all the metal that's in there. And you're going to go ahead and slide that heat shrink over top of your resistor there and your wire. And you want to leave say maybe 1/8 of an inch on the end here so that you can connect it to your LED. If you have a long LED lead, you can leave more than that. Since I'm using an SMD LED, which has just a very small amount of connector, I'm just only going to keep 1/8 of an inch open. Then on the negative end, you're going to strip off a little bit there. Since I'm using the SMD LED, I only need about 1/8 of an inch, if that. So I have right now, I have my positive, which is red, and my negative, which is this white orange stripe wire here. Okay, so we need a LED, and I'm going to use an SMD LED off of this light strip here. I'm going to take this one off, and it's surface mounted. So there's 2 connectors, one on each side. First thing you want to do is you want to just mark with a pin which side is the positive side, so that when you connect it, you'll know which side is positive. So I marked that one with a green marker. Okay, so we're going to heat up this one side of the LED, and we're going to take the pliers and we're going to pull up, and we're going to get one side off. Okay, and now we got that one side off, and we're going to turn this around here, and we're going to gently grab that with the pliers. Okay, so we got 1/2 the LED off, and we're going to heat the other side and take the pliers and pull it off. Okay, and we have the LED removed right there. You can probably barely see it, it's pretty small. And I can see which side is positive because I marked it with a green marker there for my green LED. Okay, so first we're going to solder up the positive end of the LED. So let's slide back this heat shrink over the resistor so it doesn't get too hot. And then let's take this LED and put it in our tweezers here, and we want to make sure we have the connection open so that we can access the positive side of the LED. And I'm going to actually put that inside my helping hands to hold it steady. And the first thing I want to do is put a little bit of solder on the positive end of the LED So I apologize, this is kind of small to see. Just put a little gob there. Okay, now let's connect the positive in to the resistor here. So we're going to heat up the resistor wire just a little bit. I always like to have good heat. Good heat makes good connections. And then touch that against that wire. And just kind of hold it in place for a second so it can solidify. Okay. Give it a little tug, make sure it's not coming loose. Okay, that's good. So next we want to turn it over so that we can access the negative side of the LED. Okay, so for the negative side of the LED, we're going to pre-solder the wire here a little bit first. We're going to put this iron right underneath it. A little bit of solder there on that wire, good. And then we're going to pre-solder the connection on the LED, the negative side. Okay, doesn't take a lot. I have a little bulb there, so we're connecting the negative to the negative. Let me clean my tip on my soldering iron. Okay, let's heat up nicely. Okay, good. So you'll notice I didn't expose too much wire here on the negative side. Okay, so I'm going to slide the heat shrink back over the resistor here. And there we go. Let's go ahead and test it out before we actually heat the heat shrink. Okay, let's test it out. Let's plug our LED into our receiver here. Make sure you have negative to negative, positive to positive, and here we go. Looks like it's working. So you see it's quite bright. Here's the back of it. Now we can go ahead and shrink all the heat shrink. Now we know that it's working. So this is what my LED looks like on my wingtip here, and I actually have this connected into the same servo that my aileron is on. Uses the same wiring. So as you can see, it's pretty daggone bright. If you want, you can paint the wire white or whatever color you want with just some spray paint. You can tape it onto the plane, or you can weave it underneath it or inside it, however you want to do it. The other thing you might want to do is I cut a piece of fuel tubing and put on the end of my, put right on the top of my LED, and once you put it on there, you can secure it with some Amazing Goop or some hot glue. I definitely recommend the Amazing Goop. It'll stay on there a lot better, but that will help the light diffuse more and spread out. The other thing you can do is you can actually cut out a corner of your wing if you want to, actually, and inset the LED in there, and then come back with some Amazing Goop and go right over the contour of where the wing would be, and you can have it actually match the shape of the wing without actually protruding out like you see mine right here. Okay guys, I hope you liked the video. Please remember to subscribe and like the video, and thanks for watching. Bye.